everyone. Myself Dr. Divya, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. So, in continuation with outcome-based education, now we will discuss the CO and PO mapping for one of the modules in chemistry, green chemistry and natural resources. So for green chemistry, by end of this lecture, we will understand the syllabus. We will have a glance on the syllabus, then course objectives, course outcomes, and we'll be able to understand course outcome mapping with program outcome, course outcome mapping with program outcomes, then program specific outcomes, then justification for course outcomes, justification for course outcomes, program outcomes, and program specific outcomes. And this mapping is justified. Then key competences of course outcome with the program outcome key competences mapping and calculation of percentage of key competences for CO-PO mapping and course articulation matrix. This will give an overall course of that particular subject. For example, chemistry articulation matrix for the modules 4 and 5. That is nothing but course outcome 5 and 6. So, these we will see in detail. So, here are the contents of this session: syllabus, a glance to the syllabus, then course objectives, course outcomes, then module 4 and 5, that is the green chemistry and fuels, green chemistry and natural resources. So these are fourth module and fifth module in engineering chemistry. These are fourth and fifth module in the engineering chemistry. So in that we will see the course outcomes, program outcomes, then course outcome mapping with program outcomes and program specific outcomes, then justification for course outcomes mapping, how they are justified depending on the key competence. So key competence for the course outcomes mapping, then the percentage of key competence for the CO-PO mapping, and finally the course articulation matrix for all the different course outcomes that are in the engineering chemistry. So if you see the syllabus, module 1, it details the electrochemistry and batteries. So this will give an idea on electrode potential, standard electrode potential and their numerical problems. So it is including numerical problems. So the course outcome 1 and course outcome 2 are covered here. Then batteries, coming to batteries, primary battery or the dry cells and secondary batteries like lithium ion cells are the batteries are described and imparting this knowledge. Then corrosion, there are different types of corrosion and mechanism of corrosions are studied, how many types of corrosions, and then protection, how the protection is being imparted to the corroding material. So this includes only course objective 1. So we will see that in detail. So next is the module 2, that includes water technology. So water technology in engineering, it is very important to consider water because it is a basic solvent that is used in many of the industries in the production plant as well in the construction like civil engineering. So hardness of water has an impact on these industries. So hardness of water is important, like we have to soften the water before we feed to any or use it for any purposes like building materials. So here we will give an understanding and recall the information on types of hardness like temporary hardness, permanent hardness, and the expression that is used, how hardness is measured, so that the engineers will be readily having the knowledge when they go for the industries. Then units of hardness, estimation of hardness by complexometric method. Then potable water, what is potable water, its specification, steps involved in the treatment, disinfection by different methods like chlorination, ozonization, and external methods like desalination, reverse osmosis, and its problems. There are some problems including for hardness, for determining the hardness in the water technology module. So we will see how the course outcomes are designed for this module. So we have already seen in the previous session, and in the third module it is the engineering materials, which includes polymerization reactions, then different polymers that are used in the industries, and most importantly the lubrication mechanisms and the lubricants that are used in the machinery. So the engineer must have this knowledge, so these materials are defined and given an understanding of how they are working. So now we will see how the module 4 and 5 are being used by the engineers or the engineering students. So green chemistry and fuels, why and how green chemistry is important. So this module give an idea how the different types of green chemistry methods and synthesis. So these are the types and classification of fuels. So there are different fuels that are present, so this depending on the sources, so the composition, then calculation of calorific values, so which includes numerical problems in this module. So this is the course outcome 5 and course outcome 6. So course outcome 5 includes problems, and course outcome 6 is purely non-technical. So it has natural resources and environmental pollution, wherein different types of resources are explored and understood, and how the environmental pollution is, how are they getting polluted, and the measures, control measures for different pollutions like air pollution, water pollution, soil and noise pollutions. So these are the different topics that are being imparted knowledge to the students or the engineers, upcoming engineers. So we will see how they are being mapped with the program outcomes, ultimate BTech program. So that we will see in the details. So if you see the polymerization reaction, the module 3 is with respect to mechanism significance, and the green chemistry helps in reducing pollution in environment by using natural sources. So this is what student will be able to understand. So if you see the course outcome 1 is the electrochemistry that we have seen. Then 2 is the electrochemistry with problems. So we are applying the knowledge that is being obtained from the course outcome 1. Then course outcome 3 is the hardness of water and including problems. So that is also applying the knowledge in solving the problems. Then course outcome 4 is the comparison of different polymerization reactions that takes place, and having knowledge. So therefore it is under the understand level of Bloom's taxonomy. And course 5 gives an understanding on green synthesis methods and how they are utilized in industries and automobiles. So we are using calorific values like calculation of calorific values, so it comes under apply. Then course outcome 6 is the outline of different natural resources and their applicability in understanding air pollution, water pollution and the pollutants that cause the environmental pollution ultimately. So this is an understanding level of Bloom's taxonomy. So let us see how course 5 and 6 are now mapped with the program outcomes. So if you see from the whole modules, the course outcomes, 3 are of understanding level and 3 are of applying level from the Bloom's taxonomy. So if you see the PO1 is the engineering knowledge, there are around 12 POs or the program outcomes that are being present, program outcomes, but only 3 matches for engineering chemistry. Why? Because only the topics are relative to only 3 of the program outcomes. That is, the first one, engineering knowledge, PO1 program 1, engineering knowledge, because we are implying the mathematics, science and engineering fundamentals in calculation of environment, electrode potentials, EMF calculations and so on. So CO1 course 1 is matching with the PO1. So we will see that in the tables. This is an example. So it has a strength of 3 because 3 key competences are matching. 3 key competences are matching or vital features are matching from the PO1. From PO1, 3 are matching. So then the next one is the PO2 problem analysis, where we will be using the identify, formulate, review literature. So depending on the literature, we also try to solve the problem that is in the engineering problems. And principles, first principles of mathematics you can be used, natural sciences and engineering sciences. So this has got a strength of 1 because one of the key competencies matching. Then PO7, so this concerns with the environment and sustainability. So it has an impact on professional engineering solution in societal and environmental context, because the engineer should also have a knowledge on how it is going to affect the environment once he is establishing some startup. So this gives an understanding where green chemistry plays an important role in avoiding the pollution. So this is how it is given, and the strength is 3. It means it is having high importance in the learning process. Then if we go in details, engineering knowledge, apply the knowledge of mathematics, science, engineering fundamentals, and an engineering specialization to the solution of complex problems. So understanding knowledge and application of these 3 key competences. These are the 3 key competences that will be imparted in solving, in understanding the concept. So scientific principles and methodology, then mathematical principles, then own other engineering disciplines to integrate or support their engineering discipline. These are the 3 key competences that are present in PO1. In PO2, there are 10 key competences. 10 key competences that are present. So this will help in problem or opportunity identification, problem statement, problem definition, then system definition, then formulation and abstract, then information and data collection. For example, when we are taking fuels or the green chemistry and fuels, we are calculating calorific value. So that gives an important details for its application in the machinery. So for machinery or any industry purpose. So the importance of information and data collection is gained here from this PO2. So therefore the particular module is mapped with PO2. Then validation, for example, there is some different way there can be a methodology, so that should be validated further before they are being used. Experimental design, for example, if there is some experimental design that can, then this is applicable. So in our understanding topic, there will be some designs that can be used to understand the process. So solution development or experimentation or implementation. So these are the different key competences or the features that are present in PO2 that can be used in understanding the course perfectly. So whatever, for example, if there are only this topic and this class and this class applicable, so only 2 key competences will be mapping with that particular course. So we will see that in detail. So PO7 is also very important, like as said before, environment and sustainability. That as we see, there are a lot of industries polluting the environment. So it is very important for any engineer, for a startup, to understand the environmental effects. So this is something like non-technical. So however, they should have a knowledge of it. So it comes under understanding level of Bloom's taxonomy. So of these, socioeconomic and environmental are the major ones that comes under in our engineering chemistry part, and the one more is the political. So these are the 3 different key competences that are present in PO7. So if you see the articulation or the PO-CO mapping, there will be a tick mark that will be given to the corresponding CO and with the PO. And one observation to be noted is it should be technical or non-technical. So if you see, the first 5 POs were purely technical and the others are non-technical. So 6 PO6 from 6 to 12 they are non-technical. So justify that accordingly with the justifying statement and recognize the number of features that are applicable. Number of features that are applicable for that particular course outcome. So that will give a justification with validity. And then use a combination of words that will found in course outcome, program outcome, and that's therefore giving the justification. And that table, for example, if we develop a table with course outcome and PO, this PO1 is matching with course 1, course 2 also may also be matched with PO1. So we will be making a tabular column like this. So we will see in detail in the next slides how the table is being formed. So for example, if there are once we get some key competences, number of key competences that are matching, and upon calculation, if it is from 0 to 3, it is of no correlation. So if it is 1, it is slightly correlated with the present program, and if it is 2, moderately correlated with the program. For example, if the candidate or the graduate is taking the learning process in computer science or aeronautical, he will be having engineering chemistry as a part of his program. So that is a program. Whatever he is learning, aeronautical engineering is a program and the course is engineering chemistry. So if he gets 1 or 2, then if it is 2, it is this particular course is moderate to that particular program. Like aeronautical engineering, this course is moderate, so moderately it will be applicable. So that is how we decide. This is an example. So we will see in the final slide where articulation is completed. So if it is 3, it is substantially highly important, so that the student will concentrate more on the subject and gain more knowledge. So if we coming back to the syllabus, green chemistry and fuels has, these are the definitions, methods that are present, classification of fuels, then petroleum and its refining and different calorific values like gross calorific and net calorific values and its problems. So when does these problems come from? Because there is some issue going on. The manufacturing company has got some breakdown due to the fuel that is used. Then we come across these gross calorific value or the net calorific value that is being clearly calculated before its applicability. So the engineer should have that knowledge before he goes to the practical world or professional jobs. So we have to understand, like the candidate should understand the learning outcomes depending on that. So it is the course outcome 5. So make use of green synthesis methods, different types of solid, liquid, gaseous fuels in terms of calorific value for industries and automobiles. See, it is in the industries both and automobiles, for example. So it is in the level of apply, because we are applying some mathematical knowledge and engineering knowledge in retrieving information. So it is in the level of apply. So this is how it is being detected for the Bloom's level. Then coming to the program outcomes and its mapping. So for module 4 or the green chemistry and fuels, So it comes under course outcome 5. So it is mapped with program outcome 1, because we should have engineering knowledge of that particular topic. Then it is also mapped with course program outcome 2. So program outcome is whole for the BTech graduate. So it is also mapped for 2, because it includes problems that to be solved, and also to the 7, because it is related to the environment and sustainability, because this green chemistry helps in resolving many problems due to pollution. So it is also mapped with PO7. So if we see the other modules in the previous session, we have mapped only to 1 and 2 because there is no green chemistry in that. So this plays an important role. This mapping plays an important role for a student to understand, because this PO7, if we see this, why is it mapped? Because it is having the environment and sustainability that is applicable to this green chemistry and fuels. So this is how we map with the course outcomes. So coming to the module again, like student will be able to understand. So what are the different, there are 3 key competences. What are those 3? Explain. So that is the basic engineering knowledge. Then mathematical expressions, problem analysis, and principles of science. So these are the 3 different principles of science, because engineering is a branch and natural sciences or the sciences has a different principles both together. The other discipline is used by the graduate to understand the principles of engineering so that he will be able to solve that problem. So that is why it is having 3, it is matching with all the 3 competences of PO1. Then PO2, identify the given problem and formulate for finding the calorific value and information data collection. If we see that, if we see, we have so many, out of 10, only 2 are matching for us in that particular module, because identifying the problem and then data collection. So 2 are matching. That is why we have given 2 key competences are matching for the particular module or the topic. Then PO7. In PO7, it is matching with 2 socio-economic and environmental. There is no political value here. So therefore, no political value here in this particular module or course outcome 5. Therefore, only 2 are matching and 2 is being given as a number of key competences for this particular course outcome when it is mapping with the PO7. So if we have these are the number of key competences. If you see in detail, out of 3, 1, 2, 3, 3 of 3 are matching for the program outcome of 1. Whereas for program outcome 2, there are 10 key competences, but only 2 are matching: problem identification and data collection. And in PO7, only 2 are matching. Out of 3, 2 are matching. There is no political value here. Therefore, only 2 are matching from socio-economic and environmental. This is how we build a table with mapping program outcomes, number of vital features with the course outcome, that is for this particular module. If we take the percentage, 3 by 3 into 100, that is nothing but 100%, whereas it is only mapping with the 2, so therefore it is 20%, and this is mapping with the 2 out of 3. So it is 66% of key competences that is matching with the course outcomes from the engineering chemistry. So this is how we calculate the percentage of key competences. Then if we coming to the module 5 or course outcome 6, so natural resources and environmental pollution. So this gives an understanding of what are the natural resources and what are the resources that are used in and their problems. Then land resources, then renewable energy sources, renewable and non-renewable energy sources, then pollutions, what are different pollutions and how the pollution is taking place. So this, we are having a knowledge of these topics. So we are at the understanding level of Bloom's taxonomy. So this gives an outline. We are using a verb called outline because we are only having an understand. So we are not implying any formulae for calculation. So we are only using the verb outline. So natural resources and their applicability for understanding the pollutions, different types of pollution, how they are causing. So therefore it is in the Bloom's taxonomy of understanding level. Coming to the mapping, CO's course outcome 6 and program outcomes. it is matching with 1 and 7. Why we are not quoting for the 2? Because there are no problems involved in numerical problems involved in this module. So therefore we are not ticking for 2. So therefore why this is the understanding level. So engineering knowledge is required and it is under environmental and sustainability. So it is mapping with the program outcome 1 and 7. So this is how the final course outcome 6 is mapped. So if we see in detail, 1 will give an understanding and living and non-living things. So explains then principles of sciences. It means that in the, out of 3 of PO1, only 2 are matching. 2 are matching. No mathematical principles. So 2 is given. Then in 7, make use of renewable, non-renewable resources, control measures of air pollution, water pollution, soil pollution and noise pollution in socio-economic and environmental sustainability. So environmental context for sustainable development. So out of socio-economic, political and environmental sustainability, it is matching with, out of those 3, it is matching with only 2. So we are giving 2. So this is how the key competences from a PO is mapped with the course outcomes. So therefore, it is given here 2 out of 3, 2 is matching and again out of 3, 2 is matching. Therefore, these are the details, scientific principles and other disciplines, support of other disciplines are taken to understand. And coming to the environment and sustainability, PO7, socio-economic, 1 key competency and then environmental, other key competence. So out of 3, both the POs are matching 2. So if we take the percentage, 66% for both of them. So 1 and 7 is mapped with course outcome 6. If we come to the course articulation matrix, this is the overall course outcome matrix. So this is called as course articulation matrix for PO PSO mapping. So for example, the whole program is like a BTech program. He has this particular course. So that is nothing but course outcomes. So each module is been divided into outcomes and there are 6 course outcomes. So CO1 to CO6. So in program outcome 1, engineering knowledge, it is matching with 3 of 3, 3 by 3 for all the different course outcomes. But in the 2, it is matching only few of the topics are matching with this because of their numerical problems. And for 7, only module, course outcomes 5 and 6 are matching because of environmental and sustainability. So this is how an articulation matrix is prepared, and based on these total and average values what we get from this, we finally give a conclusion how important is the topic and how the learner has to plan in better learning. So it is prepared with the CO and PO and CO and PSO on a scale of 0 to 3. So 0, no correlation, and 1 being slightly correlated, 2 being moderate or medium correlated, and 3 being sustainable, substantial or highly correlated based on the strategy. So this is how we divide, we give an importance to that particular topic. So this is the discussion we had in this session. Syllabus, course objectives, course outcomes, module 4 and 5, that is green chemistry and natural resources and pollution, natural resources. Then course outcomes CO5 and CO6. Then program outcomes that are mapped. So most of them are PO1, PO2 and PO7. Out of these 3, some topics are mapped only to 2. Then CO mapping with PO are the program outcomes. Then justification of CO mapping, CO PO mapping. The key competences that are vital features that are matching with the course outcomes, then percentage calculation for that COPO mapping, and course articulation. Finally, course articulation that we have discussed. So this is how the before we initiate the learning, it is being calculated and formulated with the program outcome so that the learner has a better learning in and getting learning outcomes. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.